So now students, moving on to the next part, that is the types of polynomials. Now before moving on to these types of polynomials, let us first of all recapitulate one more topic from our class 9, that was the degree of a polynomial. Now what's the degree of a polynomial? Degree means what? The highest power of the variable in a polynomial. Whatever polynomial you are having, the highest power of the variable. Say for example, one polynomial I am taking, say the polynomial px represented as 3x square plus x plus 5. So this is a polynomial I am having. Now in this polynomial, what is the highest power of the variable? So first of all, find out where are the variables that you can locate in the polynomial. So you can see the polynomial is over, means the variable part is over here, the variable part is over here. So these are the two variable parts in the polynomials. So out of these two, what is the highest power of the variable? Here excess power is 2, here excess power is basically what? 1, nothing, that means 1. So the highest power of x is what? 2. So the degree of px is what? 2. Am I clear? So degree means what? The highest power of the polynomial. This is clear? So based upon the degree of a polynomial, we basically categorize the polynomials into different categories. Fine? So please note it down. So based on the degree, if I'm just making one table so that it's easier for you to understand. So first of all, write down the degree over here. The degree can be 0, degree can be 1, degree can be 2, degree can be 3, degree can be 4, and so on. So these are the degrees. So based on the degree, you can categorize them into types of polynomials. Fine. So types of polynomial, if it is 0, so the type of polynomial is basically named as what? Constant polynomial. This is constant polynomial. If the degree is 1, you will call it linear polynomial. If the degree is 2, you will call it quadratic polynomial. If the degree is 3, you will call it cubic polynomial. If the degree is 4, you will call it biquadratic polynomial, and so on. The categories can be means the types of the polynomials can be categorized into so many things depending upon the degree. So basically we just need to look onto these polynomials up to degree 3 only, which is there in our syllabus. This degree 4 is also not there, but since these are certain extra things, so I have written it over here. This is not mandatory for you to memorize what biquadratic polynomial is. So basically this is a type of polynomial, and let us write down the standard form of it. Standard form. So the standard form is here. This is simply a, where a is a constant. Here it would be ax plus b. Here it would be ax square plus bx plus c. Here it would be ax cube plus bx square plus cx plus d. Here it would be ax to the power 4 plus bx to the power 3 plus cx square plus dx plus e. Now out of all of them, you need to understand here a should not be is equal to 0. So let us first of all understand the names of the polynomial is something where means nothing new is there. So you need not but I should say that the types of the polynomials are not that difficult. Just you need to memorize the names of the polynomials. Degree 0, degree 1, degree 2, degree 3. Now here what we need to understand is the standard form of the polynomial. Now the standard form means basically what? Ki in general form. That in a generalized form, how will you write down those things? So here, if we are talking about constant polynomial, so we are seeing constant polynomial is a. So what does this constant polynomial signify? That means there will be no variable part in the polynomial and it would be comprised of only and only constant. Like for example, here what you can give one example as, say the polynomial is written as 7, simple 7. So the 7 is not having any variable part associated with it. So that's why you are calling it polynomial. Now you can say it's a, we have studied that the polynomial must comprise a variable. So if you see the definition in my previous video, I have written it might comprise of a variable or constant or both. I have written or, not and. Or means what? Either it would be comprised of only variable only, or it would be comprised of constant only, or it will be comprised of both the parts, variable as well as the constant. So here, if it is only constant, then also it's a polynomial. Still, some people have got this kind of idea that no variable part must be there definitely. So I must say, for those students, I can write it down in this form: 7x to the power 0. X to the power 0, anything to the power 0 is always basically what? 1. So 7x to the power 0, so that means what? X to the power 0 is 1, so 7 into 1 is 7. So by that definition you can say this is nothing but 7 only. So just in order to write down the variable part along with it, so I have written x to the power 0, and based on this you can see the variable's highest power is once again what? 0, so that's why degree was 0, and that the type of polynomial is known as constant polynomial. So I think constant polynomial is clear. Fine. And the next part, here a should not be equal to 0 for all of them. I have written for all of them a should not be equal to 0. So a is a constant over here, the constant should not be 0, because 0 means what? Nothing. If it is nothing, so that means this is not a polynomial at all. Because you need to write down something, you need to give something to the polynomial. You cannot just simply put 0 over there. Apart from that, the next polynomial is linear polynomial ax plus b. For example, if I am writing the example like this, like 4x plus 2. So this is a linear polynomial. 4x to the power 1 plus 2. So the highest power of the variable is 1. So this is a linear polynomial. Here you need to understand, a linear polynomial can also be written like this, simply 4x. Or it can simply be written as x. You need to understand one thing, that the constant part may be vanished from the polynomial. It doesn't matter. What matters is that a should not be equal to 0. That means coefficient of x. That means the part or the term which is defining the degree of the polynomial. The term which is defining the degree of the polynomial, that term's coefficient of the variable. That means this is what x's value is, x's power is 1. So this term is basically determining the degree of the polynomial. So if this is the one which is defining the degree of the polynomial, then this particular term's coefficient, that means the a part should not be is equal to 0. That means if this becomes 0, then 0x means what? 0. So this is gone. Simply 2 will be left, and if 2 is left, that means what? That the degree of the polynomial is nothing but what? 0. So that means that will become a constant polynomial. So that will not be fulfilling the criteria of what? The linear polynomial, being the degree of the polynomial to be 1. So based on that you can say the coefficient of the variable which is defining the degree should not be is equal to 0. This is clear, and it can be comprised of simply 4x. That means if the constant part is not there, even if the constant part is not there, still you can say that the polynomial's degree is 1 only. So that means if the constant is not there, still the degree would be 1. So that means it is still defining the criteria of linear polynomial. I have written the standard form. I have written over the standard form. Now everybody must say that if you are not writing down the b part, like for example in these two cases, we are not writing down the b part, that is the constant part. So how come the criteria of the standard form is fulfilled? See, the standard form is an in general form. In general form does not mean that this should be the form in each and every case. Even if you want to put it in that form, so you can write it down as 4x plus 0, making it what? That the standard form. That is ax plus b. So based on this, you can say this becomes 4x plus 0, fulfilling the criteria of the standard form. So again, writing down this 0 will not create any kind of new or extra things. So based on this, I can say that even if I not write down that 0 part, then also it's okay. Similarly, the quadratic polynomial, its standard form is written as what? For example, 4x square plus 2x plus 3, or you can simply write it down as 4x square, or you can write it down as 4x square plus 3, like that. Different examples. You can say the main point is that the degree should be 2. That means highest power of the variable should be 2, and the coefficient of that part which is defining the degree, this x square part is defining the degree. This x's power is 2, the highest power is 2, so that means this x square's coefficient, that is a, should not be once again equal to 0. And this is what a quadratic polynomial is. Similarly, if you need to define cubic polynomial, you can define them. The main point is that you need to understand the coefficient of the term which is defining the degree. The coefficient of the term which is defining the degree should not be equal to 0. So this is what the degree and the types of polynomials. So please pause the video to note it down.